All right, let's see. Example 3, let's see, we've got an arc length, we've got 38 degrees, the radius is 5. Well, once again, I believe that you should be looking at this being much smaller than the radius. We've got 5, and then right here, again, you have to get it. So you go over 1 degrees down here, so those cancel. Again, there's nothing wrong with writing 38 pi over 180 in that blank because you're just using it to calculate it anyways. But yeah, I think a 2 comes out of them, is that correct? So 19 and 90, so 19 pi over 90, and you go ahead and you multiply that out. And what do we get? So 3.316 feet. So far, which of the arcs is actually, if I physically had it right here in my hand, of example 1, 2, and 3, which one is physically the longest? If I had it in my hand. I heard example 2 a few times, but then people kind of corrected themselves. Yes, I know that example 2 has the biggest number, but it is centimeters compared to feet. Okay, so this one is definitely the longest of the 3 so far. Okay. Now, obviously, something I could do back here is instead of giving you the radius, I could give you diameter. And that tends to get a lot of people, they get going way too fast, and they just substitute that number in, and then they get it wrong. Because, of course, you're supposed to put radius in the formula. Okay. And then, again, make sure that theta is in radians. So here, I also could do it different like this. I could give you the arc length, I could give you the radius, and ask for the angle. You use the same formula, you just substitute in for different information. For example, here the arc length is 10, the radius is 7, theta is now what I don't know. Well, then the nice thing about the previous examples is the variable was already by itself. Well, here it's not, and so we have to get it by itself, and we would do that by dividing by 7. So theta is basically 10/7. Unfortunately, if you leave that as your answer, you are incorrect. Because this problem asks for the central angle in degrees. This is in radians. So we have to take 10 over 7 and convert. Now, if I want it to go to degrees, basically you don't want to cancel out degrees, so you better put degrees on top. And so that's the form of 1 that we would choose to multiply here. I know that you can't cancel off the pi this time, but remember that did happen earlier in this chapter. And so if you look at it like this, it's basically 1800 divided by 7 pi. But if you're going to type that in, make sure you have 7 pi in parentheses. Otherwise, it will do it incorrectly. And in a second, I'll go to the calculator and show you the difference between the two. Everybody's got it written down, looks like. So what was it? 1800 divided by 7 pi in parentheses. So should this be the one that gives me the correct answer, or is this the incorrect way of typing it in? Yeah, this is correct. It's going to divide by the entire 7 pi. And it doesn't really matter what mode you're in. It's going to take care of it for you. And if we round the way we've been doing, what will we say? About 81.851 degrees. Or, maybe it says 10, so you'd say 81.9 or something like that. So just keep an eye on how it wants you to round. And just to show you, whoops, hit it too many times there. Just to show you, unfortunately, it knows order of operations. It takes 1800, divides by 7, and multiplies by pi. Multiply and divide from left to right. Okay. So watch out for that. Any questions on any of those? Well, there is potential for extra credit here. You can give me the answer in degrees or in radians, and either way, round to the nearest tenth. You may notice this particular example is the very first time that the arc length got bigger than the radius. correct? The arc length was 10, the radius was 7. In all previous examples, I made sure that the arc length was less than the radius. So obviously somewhere along the line, this changes over, right? Because this is what, 81.85 degrees, right? Isn't that what we came up with? And so we need to find out, and what you need to find out if you want the extra credit, is obviously along the way, there is some place where they will be exactly the same. The arc length and the radius will be equal. And then after that, the arc length will get longer. For extra credit, find out where are the arc length and radius equal. Okay? So that you can just add on to your assignment for tomorrow.